So you're building Mira, the trust layer for AI. What is the trust and verification layer for AI?
Yeah, I mean, I'll give you a bit of background of how we got here, right? So, when like the campaign explosion of like AI models started, this was like mid 23. Like me and my co-founders, just like everyone else, was like building everything that we could, and we were like, this is the future. This is going to change humanity. This is like, no one will ever have to work a day in their life. And then we built an actual AI product, and it sucked. And this is probably what every AI builder goes through, and without exception. And you can see this in like both first hand and second hand information, right? Like first hand, if you ever try to use any of these agents, you realize that they're great toys, but you can't really do anything useful with them. And second hand, if you look at like enterprise data, 95% of all uh, AI pilots fail, and then companies just revert back to using humans because humans are actually reliable. So I think the big disconnect has always been AI gets you to like 80% of what you need to do, which is great if it's a co-pilot, right? A co-pilot is something where you hold accountability for the final action, where if it's code, you have to deploy the code, and if the code sucks, then like they'll fire you, right? Or if it's like writing and you kind of use AI as an assistant writer, but your name goes as the publisher of that particular document or whatever. But no one uses it as a real agent. And agent is when the accountability actually lies with the AI model. And people have tried, right? This isn't for the lack of trying. People have tried to build trading agents, they've tried to build a bunch of stuff, but they all suck because of like how the distribution of outcomes is in any of these things. Where if it's any use case with decently high consequence, even though you might get a lot of value by AI getting things generally correct and doing the right things, the the probability of loss the amount of loss in case of a loss event, even though the probability of that event being super low, is very high, right? So a good example is I had a trading bot, I built it, I'm like, this is going to change the world. I deployed it to do a bunch of DeFi yield farming, and it was generating like 15% APY on stables, right? I'm like, this is phenomenal. I don't have to work a day in my life. But one day it made a mistake and clicked on an exploited contract, and I lost half my portfolio value. So it just took one error to make me lose like 50% of my portfolio, even though it was doing everything right before that.
Okay,
And
so
we
yeah, I
were
mean,
like,
listen, I can agree that there's too much hallucination, and you kind of need to be at 100% to trust it with a whole lot of money. But like, what are you guys doing to actually solve that?
yeah, it's simple, man. So think of how prediction markets work, right? Prediction markets basically say that wisdom of the crowds help you to kind of triangulate the truth and triangulate what's correct. We use a similar philosophy when it comes to figuring out what's actually an accurate answer. So we, instead of using like a single model which has its own distribution of hallucinations and biases, which is based on the way it's trained, we use consensus among multiple diverse models, which have been trained differently and have hence different distributions of probability bias and bias. So what ends up happening is the same model, the same three models won't hallucinate on the same thing at the same time. And we've actually published research on this. You guys can check it out. It's on our website. But we've been able to reduce hallucination rates by like over 90% in a lot of like real high consequence use cases. So
Are you kind of zeroing in on a few specific use cases like, agentic finance, or do you see this being a core part of just like the chat GPT in the future, or kind of more consumer use
this
cases?
is, I would say, most useful for autonomous agents, primarily because, as you understand, with more models comes more cost and latency. So
Yep.
you can't directly compete with like a human interface product where you need answers directly. But think of like a trading agent, right? Where you don't care if the trading agent trades within a second of you texting it, but as long as it consistently trades over time and delivers returns, you're okay with it. Or if you're using AI for like bulk use cases. So, for example, one of our first customers was a Delphi Digital, and their issue was that a lot of customers would read reports, try to interact with their reports, but the AI bots that they were building within their website were like just giving them false information, and which is not actually in the report. And the risk there is that you're kind of financially liable if someone acts on an AI agent which is on your website. So there's great immense value for them to deploy something which is much more high fidelity and high integrity from an AI infrastructure perspective.
Can you give me a sense of like how much more latency and how much more cost is involved in here? It feels like that might narrow the use cases here. And then do you see solutions to scaling that?
the first thing we try to solve for, and we have solved for, is cost and latency. So we use a technique that we've like developed in house called binarization and sharding. So it's a very simple technique. It basically says that you might put like an entire body of text to the AI, right? Like it can be a report or whatever. But within that, there are only certain amount of binary yes, no facts or statements. This can be like, for example, if it's a report on crypto, then Solana's, FDV on X date is XYZ $1 billion. Now that's a fact. That's either yes or no. There's no like ambiguity in that. So our system, what it does is able to extract these facts in real time, and it runs them in parallel, and then it aggregates them together. So if in case you have a statement with 11 facts, instead of running that whole statement sequentially into multiple models, you can run those 11 facts in parallel and then aggregate that. So you basically drop your latency by like you drop it to like 1 by 11 of what it would be. And what this also allows us to do is, if you think of every fact being binary, then the output to verify the fact being binary is only a simple yes or no, which is in AI terms, it's one token. So instead of like having and in AI also, output tokens, which is the tokens that the model actually puts out, are usually 5x more expensive than input tokens, which is the model tokens that the model ingests. So with that, we're able to also reduce the total cost of tokens significantly, which is the main cost driver for any kind of AI system. So this is how we're able to kind of significantly scale, especially for large texts and large bodies of information, and also keep latency, quite low. Latency and cost quite low.
Can you guys talk about how, I think you mainnet a couple of weeks ago, you launched your token. Can you talk about how the kind of token economics and kind of blockchain component work?
Yeah, so if you think of what we're building is basically an integrity system. An integrity system, we realized very early on that you cannot have any centralized party to trust, because then we will control the verifier. We'll tell you that we're verifying everything and just give random yes, no answers for everything and keep all the, basically we'll be a 99% gross margin business if that was the case, right? But I think there's value in it being decentralized, just like how there's value in a network of value like every blockchain is to be decentralized, because then no single node can really, maliciously, or in our case being a lazy validator, impact the quality of the output. So what we do is each of these models are basically what we call verifier nodes. They're distributed. People can stake our Mira token with those verifiers. And then if in case any of them act in a manner which is, not aligned with the network, there's slashing risks that come associated. The more economic value we have as a network, the more economic security we have, and the more quality of the quality and integrity of the outputs we can keep. So it's, I'd say, broadly aligned to how blockchains work in general, just applied in the context of AI.
So I'm intrigued by like how you take this to market, because I think there is just this explosion of infrastructure, applications, models, approaches out there, and it seems like your ability to go get the specific use cases that really need this level of verifiability is absolutely key to growth of your business, growth of your token, etc. So how are you approaching that, and who are some of the early users of this infra?
Great question. So I would say there are three stages of how we approach EDM, right? It's very similar to how other research labs look at it as well. There's the API business, where we basically go to developers and say, this API, and if you think about it, we're basically offering any model with a layer of verification wrapped around it. We call it a synthetic LLM, effectively, right? Because you can just use GPT-5 on Mira's platform with like a verification layer, wrapped around it, so it's lower hallucination. So the cell is very straightforward. We've made it like super easy to integrate this with our SDK, with any existing application. The second layer is actually pretty interesting. Is we've realized that most businesses, enterprises today want to use AI but really don't have a clue how to use AI. So we've taken like a leaf from the book of like companies like Palantir and stuff, and have kind of start bringing on board forward deployed engineers who can actually go into companies, solve problems, and then use our infrastructure stack to like expand within those organizations. And the third is, I think, what is a lot more ecosystem driven, where you kind of foster early applications, early builders who are building on top of your stack. So a few that stand out is GigaBrain is one which we kind of got on board early. It's a trading bot on Hyperliquid that autonomously trades. It opens and closes positions based on like news and signals that it gets. It's one of the few that's completely automated, and it used to have like a really good win rate, but the aggregate PNL used to be terrible, because when you lose really badly, right? If you hallucinate. So we were able to actually reduce those hallucination rates meaningfully to a point that now it has like, I think over the last few months it has an actual, positive PNL, and it's kind of going quite strong. And then in the Web 2 world, we have a few interesting applications as well. So we work with this educational startup called LearnRight, whose job is basically to take a bunch of textbooks and convert it into competitive exam, questionnaires in real time. This is a job usually done by like humans, but you basically completely remove the human and or replace it with an autonomous system. But you, of course, every question cannot be like, they would actually have a hallucination rate of like 20% before Mira got involved, and now that hallucination rate is like 2 or 3% and like reducing month on month.
Interesting. All right. So I think Josh mentioned the big news last week was you kind of launched mainnet, launched a token. Obviously, the timeline was in an uproar over Binance and listing fees yesterday. I believe you guys listed on Binance. So I'm curious what you think of the recent controversies, and why you chose to list on Binance. And you think that was a smart idea or not?
Yeah, I think it's a good question. It's really dependent on like what the goals of the teams and the projects are. It's a function of how much you want to de-risk upfront versus willing to take the bet and build over time, right? I think we were in a position where we felt like we could actually secure a listing because it's not guaranteed for most projects. You still have to do a lot of groundwork in building your product, your community, all that. And what you get with a Binance listing generally is you get in like access to a lot of potential investors and token holders who will actually kind of work with you, and you get access to volume that you would not get on chain. And people underestimate the value of these two things because nobody wants to trade your token if you don't have volume, and it's very hard to create volume where it does not exist. It's unless you're like super lucky that you're the one company in that one meta that consistently kind of operates over like a 3-month time frame for you to be able to generate volume. It is usually not the case. For every one on-chain success, there are like 1,000 on-chain failures. So we just felt, given the mission of our product, given how important liquidity is to the kind of long-term vision of what we had, working with someone like a Binance, completely made sense, and I don't think we really regret that so far.
Awesome. Well, thanks for jumping on with us today, man. I think we'll have to leave it there, bring our next guest up. But yeah, very intrigued about what you're building. I think you have a kind of a flagship app that people can go use if they want to kind of get a sense of the product. What's that called?
Yeah, so we have an app called Clock. Think of it like ChatGPT, but with a verification layer built in.
Nice.
You can check it out at clockapp.ai. It's free to use, at least the free tier is, and feel free to check it out. Give us feedback. We're always happy to learn.
How many years till AGI?
I don't think we're ever getting AGI.
Ooh,
AGI is always
love it. Karan, man, appreciate you hopping on. Best of luck. I think you're in a competitive space, but man, is there just a ton of potential there. Make LLMs true. It's a t-shirt. There you go.
Thank you guys.
All right, brother. Cheers.
Peace, man.